Hey guys, this is Jesse who is not good at algorithms. I'm going to receive a front-end engineer interview just the next week. There's not much time left. In this video, I'm going to take a look at 766. It's an easy problem called Toeplitz matrix. A matrix is Toeplitz. Toeplitz? Am I pronouncing it right? Toeplitz? If every diagonal from top left to bottom right has the same element, or given n by n matrix, return true if and only if the matrix is Toeplitz. So matrix is like this. If, like for each diagonal, they're the same. Okay, so it's diagonals. It's true for this 2, 1, 2. So now, while for each diagonal, actually there is a characteristic of the coordinates. Actually, if they are on the same diagonal, the sum of their x and y's, the indexes, should be the same, right? For here, it's it's not the same, but it should be has the same diff, right? For this coordinates, wait a minute. So for the coordinates is 0, 0. This is 1, 1. They are the same, right? Okay, so now here it's 0, 1, 1, 2, right? You see the difference between the coordinates are the same. For this one is 1, 0. Okay, this one should be 1, 0, 2, 1, right? 2, 1. Yeah. So if we label each diagonal with this difference, it would be here. It would be mn, right? So this should be m0 m. This is one b. Okay, let's see. So here it should be m 0 and m minus 1 minus this one should be m minus 1 and then 0, 0, right? 0, 0, and now here should be minus 1 2 to what? 2 minus 0 and minus 1. Minus 1. I made a mistake. This should be n minus 1. N minus 1, 0 to 0, and then 0, 0, 1 to n minus 1. Well, if we sum them up to sum them up with what? With n minus 1, it should be n plus n minus 1 to 0, right? So you see it's 0 from 0 to m plus n minus 2. The n by n here is 4, 3. So 0, 1, 0, 1. The amount would be m plus n minus 1. So 0, 1, 2, 3, 1, 2, 3, 4, 5, 6. 6, right? 1, 2, 3, 4, 5, 6. So it's 6, n plus n 7 minus 1, 6. Yeah, that's all. So the index will be 0 to 1, 0 to 5. Cool. Yeah, plus remember to plus n minus 1. Great. Let's create a result. So, no, we create an array to hold the elements of each diagonal. So the elements would be new array. How many are there? Oh, we need to so rows equals matrix dot end const columns equals matrix 0 dot end. Here's the problem: we use this 0. It might be empty. Let's see if they valid. Matrix, okay. Make sure you have a number of rows in integer. Wow, so it's valid, so we can ignore it. Cool. Now, so elements will be rows plus columns minus 1, right? We don't need to fill anything. Yeah. Now, for let I, we loop through all the numbers. The index, we will calculate the index by sum up their x and y's, right? I and j means comes index. The index equals to, we already done it, so it's I minus j plus the n minus 1, so cos minus 1, right? This is the index. If it is 0, so okay, the last one should be 0 minus columns minus 1, so it's 0. This is index. Okay, if the index is undefined, so it means no element is set. We set it. Matrix I and j, right? And if it's not set and it's a different number, then what? It's against our rules. Return this. And finally, nothing happens. Return true. I think it should work. It's just review one more time before we submit. Okay, the rows, the elements we initialize with rows plus columns minus 1. M plus n minus 2, just because it's from 0. Yeah, sounds cool. So the rows, the columns, the index will be, you see, I minus j plus columns minus 1. This is what we did here. This is actually the first part, the plus and minus 1, and we get this. Right? So this will be unique. It's undefined, we set it. And if it is different, we return false. Sounds good. Cool, let's submit. Yeah, we're accepted. And let's analyze the time and space for this one. Oh, it seems that we're using a lot of memory. Let's first try to analyze our time here. Time, it will be actually, time will be linear time. Yeah, we traverse through all the elements. It's m, n, okay? Okay, so for the space, we use one array to keep track of the elements. So it's m plus n. To be accurate, it should be like this, but yeah, it's a big O notation. So could we improve this? Oh, I see. I think that we are overdoing this one. Actually, if the Toeplitz matrix, if it's valid, then this top 2 is also valid. So we can see that actually this will be one index shifting, right? So this one be previous one. So actually we can compare this one by one and get the result. The time will not change, but space we don't need to keep track of the items. Wow, this reminds us another one. We're overdone it. we're overdoing it. Let's try to do it with compare each row with one item shifted, one index shifted. Okay, so okay, this will be true. This will be needed. We loop through each row, and for each row, actually, we will start with for the next row from 1, and the item will start from 1. So we'll just check if matrix I j doesn't equal to matrix I minus 1 j minus 1, right? So if this does not equal to this item, yeah, return false. Also, this should also work. Yeah, the first one actually, about the idea is very important. I must say the first this idea is very important for the matrix problem. I have done several problems of matrix which all leads to this solution. But for this simple one, actually comparing by rows will be sufficient enough. Will suffice. So let's try to submit. Wow, still we use a lot of memories. Whoa, if this okay, for time, this will be linear mn space. We don't use any space, man, so it's constant. Wow, this is not even fast than it's bottom 25%. What? Could it be any faster? I don't know. Let's take a look at the solution. So this is the first one, I think. This is the first solution we did. Compare neighbor. Actually, we're doing the same, but we're just as slow. I don't know. Let's take a look at the solution. Wow, this one is very fast. What we actually, technically, we are doing the same, right? Man, you see. He's comparing the from the previous one to the next one. What we are doing is comparing from the next one to the previous one. Well, really? Does it really makes any difference? I don't think so. We're technically the same. So I'll stop here. Hope it helps. See you next time. Bye bye.